Hey, this is first devlog of my game I'm working on for some time. Since it's the first one, I will show to you my game, what's the idea behind it. It's pretty novel. I haven't really found anything like this so far on the market. It's really captured the flag strategy-wise thing, but well, real-time strategy maybe, but the main thing about it, the most fun in my opinion, is that you don't have so much control as in other strategy games. So the idea is that all the players are actually controlled by LLMs, so the AI models. Currently, just OpenAI models, but in the future, I want to provide in the game more how I call it AI vendors. I don't know if that's how you should call it, but AI providers, let's say. So currently it's just OpenAI, but in the future I want to give the players capability to use Gemini, XAI, meta models, etc. There are some of the most important players on the market. And also I like there to be an option to be able to attach to some your own models you manage on your local PC or just in a local network, as long as you are able to provide chat LM capable interface for communication. The same way as OpenAI. OpenAI has those endpoints that you can talk with an LLM once you provide your API key. And so let's start with the introduction. I will just show to you how the main menu looks, and it will be our starting point. So, well, the game uses LLMs, so you have to provide your own API key. So I will just copy mine into there. Now the OpenAI backend is initialized. It's already done. So now, well, we have to add some teams. That's the idea behind the game, that that players are divided into teams. So each team is an enemy to each other, and well, currently, and I think it will remain as this. Currently, the game supports maximum of 50 players, but they can be divided into teams however you want. Sorry for my throat. So you can have two teams, 49 players, one, and the second just one player. But but just as well, you can have 50 teams of one player. So I can have like this. So now I have now I have 8 teams here, but let's stay with just 3, and three teams with three players, and what we can configure here. We can configure there's actually three levels of configuration just to make things easier. You can configure per player, but if you don't want to do this, because it would take some time to configure each player separated, that would be kind of time consuming and, well, not so easy to play this then. So you can, it's actually checked on by default that the player is using team's default model. So now we'll configure this player, but we can also configure whole team at once. And well, for team it's very analogical situation regarding the model and also other settings, but let's focus on just the model now. So just like for the player, when you're configuring the team, you can also, it's checked on by default. When this is checked, the team is using model configured in so-called game defaults. So this is top level settings in settings hierarchy. So if you set here you are configuring the model for the whole game. So you are choosing the OpenAI as LLM provider, LLM vendor, as I call it. As I said, currently we can only choose OpenAI. By default, there are GPT 4.1 Nano, because, well, it's chosen by default because, in my opinion, it's the best model for it has the best balance of best ratio of speed of response and cost of the tokens. So that's why the game is using this by default. So here in game defaults you are configuring this model, and if you want some team to use other model, then you can uncheck this and choose, for example, for one mini or for one this base, the greatest, most intelligent model from this 4.1 Nano family. So you can do whatever you want here, but if I check this on again, this team will be using game default. So this. And with the players, with individual players, situation is very similar. So this is checked by default, but if you uncheck, you can set model for the player individually, and even though the team is using for one mini, let's say for now, you can say that this player will be using for one base, for one nano. I don't know. And also, if you have this unchecked, but in team settings this is checked, then the team will be using game defaults, but the player The player will stay with the same situation. It is configured individually. But let's say we have all the settings provided through the game defaults, since all of those have this checked. You can also provide names for the players, but this is just visual thing, just for your convenience. You also can name teams, but I imagine this as a player, something like player tag, so it's just maximum for characters. So you can put there more than 4, but let's keep the default one. Also, well, so we talked over the models thing, but the idea behind the game is that you are commander, so there is much more to it than just setting the model. The most important thing about being the commander is well, giving orders to your warriors, let's say. So you are providing behaviors. This is we'll come back to it in the second part of the devlog, when I will be showing you the behavior editor. But let's say it's something you can you can kind of give orders to your players in terms that you are defining their behaviors. So you're establishing that for example, when they're close to enemies, they're trying to attack the enemies and eliminate them from the game, but if not, they're just going to the flag, because the point of the game is to capture the flag, and when capturing the flag, you are gaining 1 point, and the more points you have, the stronger you are. So this is actually one of the simplest behaviors I could think of. And you can create your own behaviors, but also there are some built-in behaviors. So the one I was talking about, the one about attacking the other player if we are close to enemies. This is essentially what this aggressive behavior does. There are also other ones in the built-in behavior list, but we'll come back to it later. Also there's this prompt history setting that might influence how intelligently the model will be behaving, because when we have this prompt history set to 1, so the default minimum, he doesn't have any insight in his previous moves, so we can't look back into history and how he came to some conclusions, and how other teammates and enemies were moving. So we can't come up with any conclusions based on history data. But if you make it longer, this history buffer, then who will be able. It's not guaranteed that it will be more intelligent. Maybe there's even a chance that he will be more confused because he'll be getting more data on the input and getting confused and coming up with some weird conclusions. So there's no guarantee, but well, that's the beauty of the game, that you don't have so much control. You're just giving orders to your players. How do you want them to behave? Like what you want them to achieve, but how they do it, and the decision if they even decide to actually do it is up to them. So let's start with some first simple presentation game with these settings. So everyone is using this aggressive behavior. Everyone is using this aggressive behavior with GPT-4.1 Nano, and we have 3 teams with 3 players each. Let's see how this goes. I have some sound muted. Wow, and there are some mechanics about what happens when 2 players collide. So when 2 players with different point values, so different strengths are colliding, then the second one or the weaker one gets eliminated. But when teammates collide, or when players of equal strength are colliding, then there are so-called panics, or that they're doing one step in random direction. Now we have 2 players with 2 points, so of different teams. As you can see, when this green and the red one won the game, but as you saw the last move of the game, when the red one collided with the green one, collided with the red one, the green one was already stronger, but that didn't result in immediate elimination of the weaker one. That's because when the player is gaining a point by capturing the flag, he is unable to eliminate other players for 5 seconds or until he makes his next move. That's a mechanic that doesn't allow the bots for something like camping strategies. Let's go with one. Or maybe this time we'll change something. So let's say 1 player per team will get not aggressive behavior, but avoidant. Let's say this is avoidant is more defensive behavior, because when it's always targeting the flag, so at least that's our orders. He can also decide that he want to eliminate other player, but in general our orders it's is that we want the player to target the flag, and when stronger enemies are close to him, he gains speed. We'll come back to the speed settings because it's not setting that is available from this main menu. It's a parameter of the behavior. So for each for one player per team, we'll set avoidant behavior for it, and just so we know which one is which, let's name it AV for players that don't have aggressive but have avoidant behavior. Okay, let's go with it. Okay, I don't know what he does. Actually, he's going left, right, left, right. Now he's collided with his teammate. No. Actually, it's no avoidant player has lived at this point in the game. So, well, we have just aggressives right now. The aggressive ones, as you can see, there is sometimes getting faster. That's also the same mechanic that the avoidant players are using. It's called swiftness, but as I said, we'll go back to it later when I'll be talking about it's called swiftness, but it's the same mechanic as in avoidant. So in aggressive it works like that, then that and red team won. In aggressive it works like that, kinda inverse what avoidant does. When you are close to stronger enemies, we are gaining more speed, so we can react faster and also actually move faster. And so there is more chance to actually eliminate the enemy, because when aggressives are close to enemy, we want them to actually target the enemy, and the faster they can react to it, the more chance they have to actually get them. So that's why they're gaining more so-called swiftness in this case. And I will observe some situation in a minute. Oh, in this case, this was moving much faster, but collided with that's because when model is starting to think on his move, he's getting map state, so where his teammates and enemies are currently, and where flag is. But well, the thinking process is taking some time, so until he actually come to executing his move, the map state will change. So that's why he will collide with other players, because well, the map state actually changed since he made the decision. And also that's exactly why the high swiftness, the high velocity in aggressive behavior is so important when that's why he's in aggressive behavior is getting this high swiftness. So he's okay, I'll explain shortly the swiftness parameter. Swiftness is parameter that defines how many steps the model can generate, and also the higher the swiftness, the higher the swiftness, the faster is the movement speed of the player. And swiftness to the number of steps that model is generated is other way around. So the higher swiftness, the higher movement speed, but also the lower number of steps. So for example, maximum swiftness will mean that that model can generate just one move, but the actual movement will be executed really fast. So this is actually what aggressive fast built-in behavior does. It's pretty much the same as aggressive. So when we have weaker enemies in some radius, then we are gaining higher swiftness. But in case of aggressive fast, it's even more extreme. So if I remember correctly, currently aggressive fast is configured as if you have weaker enemy in some very small radius, then we are gaining maximum swiftness. So we are maximum swiftness, so the model will be generating just one step, and the step will be this movement speed of the step will be very fast, as fast as we can get. So we have very good chance of actually eliminating the weaker player, the player just saw and decided to target. The aggressive, this normal aggressive, not aggressive fast, but aggressive is the same, but no, not so extreme. The radius of searching for the weaker player is a little higher, but also the swiftness we're gaining is is a little lower. So if I remember correctly, then it will be generating 3 or 4 steps. So the decision will come a little later, and also the movement speed will be not as fast as in case of aggressive fast. We can actually just reset all of those. Let's go with those. Also GPT-4 nano, but let's put aggressive fast behavior for all the players, and we'll see how they behave. Also aggressive fast, this default idle speed is higher than in case of aggressive. So they are doing less steps and moving faster in general, but when they are attacking the enemy, they are moving even faster and generating just 1 step. So let's see how it goes. As you can see, the game is much more dynamic. Decisions are coming up very fast. The movement is really quick. Maybe P2 will try to the blue one. Oh, okay. It's getting dangerous for greens. Oops. Yeah, the green one panicked and went out of map bounds while panicking. Also, maybe not in this match, but in previous games, you probably saw that some models went out of bounds. It seemed like out of their own decision, so kind of suicide. Well, it was in fact suicide, but probably not intentional. From what I was debugging, so just looking at their decisions when something like this happened, they are just from time to time it seems like they're just coming up with conclusions about what they should generate to be correctly understood by them. Usually it's something like they're generating instruction to go right when they want to go left or something like this. And sometimes this results in what seems like suicide. And this is most likely because we are using the least intelligent model from the for GPT-4.1 family. If we were using the more intelligent one, this probably wouldn't happen. But also the game is much less dynamic because more intelligent models are working much slower than for example this for 1 nano. You can do a test and run a game with for 1 mini, the bigger version of nano. And as you can see, the movements are not as bad. They're coming up quickly, but it is in fact much less dynamic than in case of the previous match. Let's not wait until the end of this match and try for one days, this GPT-4.1, and see how fast they come up with their decisions. No, it's already 5 seconds into the game and nothing really happened. So, well, when you are playing around with the game, the choice of the model is also important because, well, the faster the player will come up with its decision, the more precise it is, because map state haven't changed so much. The other players haven't moved so much, so their move will be more precise and up to date regarding the positions of other players and the flag. So choice of the model is also important, and those are really the two main parameters: the choice of the model and the swiftness parameter. And also there's this behavior also as well. Actually, the most important gameplay wise, I think, because, well, it actually defines the what we want as commanders that should happen. So, well, this GPT-4.1 base is also not doing so bad. It's much, and the decisions come much slower than in case of 4.1 nano, but it's also pleasing to watch, and they are coming up with decisions as fast as it is needed for movement to be actually up to date regarding other players' state. But when I was playing around with GPT-5 or 5.1 and others in the GPT-5 family, the response from a model was really slow. But that's also probably because the new models, so they're the most used by the other OpenAI users, so OpenAI servers itself are slow due to number of requests. I guess for one, since it's a little older model, it's not so widely used. So maybe that's why time of response is also better. Oh, well, the weaker one practically committed suicide because, well, that's good example of thinking too long on their decision. He started thinking about his move before the blue one got there, and he moved there even though he shouldn't have, because it was effective suicide. He just didn't know that the blue one was there in that moment. Finally, we have the result. Because, well, with this greater 4.1 model, its games are much longer due to less. The game is just less dynamic. Everything is happening slower, so that's why the matches themselves are longer. Well, I think I explained. I hope that it's clear. I know it's very novel idea about gameplay design, and that's why it's actually difficult to explain. But I hope it's clear after this. Probably it will be even more clear when I start explaining the behaviors in more precision. We'll go to behavior editor in a moment. Do I have anything to talk about in that moment of the devlog? Well, as you can see, for now it's just single player game. So you are creating the teams, you are adding the players, settings, all the configurations, how the players behave, and what models they use, etc., etc. But you can't play a match with other people through network. So it's not possible that each person will introduce their own team and their own configuration. It's not possible right now, but in the future I'd like to do it. But we'll see how much interest the game will get, and how good idea it even is for the game. I hope it's fun. Well, it is for me. I was playing around with it. Besides developing it, I was really enjoying actually looking at the matches. They can be pretty surprising from time to time. Also, for now, the positions at the start of the game are completely random. I'd like to also do something like that before starting the game. You are able to place your players however you want on the map. So then you can have more more strategic approach to your matches, because you can, for example, um, place aggressive swans on the front, and for example the guardian ones on the back, or other way around. Whatever you think is a good strategy for starting the game. But for now, the positions are completely random. So that's another, I think, big feature that I will add later. And also, I like players to be able to adjust behaviors of the LLM players mid game. So you're not just adjusting the behaviors before the game starts, but also based on your decisions, whatever you see on the screen, you can change the behavior. So just give them new orders. That's not possible right now, but that's also one of the big features I want to introduce in the future that will impact the gameplay greatly, I think. So yeah, the behavioral adjustments mid-game, multiplayer, and the third thing I was talking about. Let's go to behavior editor. And I will show you how the editor looks, and then you will be able to understand what the swiftness parameter is in the action. So when you open up the editor, you see something default, that the simplest you can get. Okay, so let's go explain what happens here, the simplest case ever. Sorry, it's from all the talking. So you have there some nodes. We'll talk about it later. That's also more kinds of possible nodes to be put in your behavior, but the key one is LLM control. That's pretty much what it boils down to. Everything here is matters of configuration of what your LLM will get. So in this case, behavior also can define what model it uses. That's why when you configuring the model in game for the player, it's called not just model, it's default model. So when it's not here, if I deleted this one, then the player will be using the model defined in the main menu in game. So for example, we can do something like this. We'll come back to it in a moment. Here we are defining some condition. Then if something happens, then we are going to this behavior. So we are targeting flag with swiftness 0. It's expressed in values 1 to 100. So so it's kind of percents. The maximum swiftness is, as we talked already before, the more swiftness you have, the faster your moves are. So, and the faster the movement, and also the faster the decision made for the movement. So with the maximum swiftness, you are doing the model is thinking about just one step to generate. So the model's decision will come up very fast, and also the execution of the movement will be with the maximum speed. You can go for something in between, and you can also go for the slowest movement, the minimum swiftness parameter. So the 0 swiftness means the maximum number of steps. So currently it's 15 steps, and the slowest possible movement speed. But it might be a good decision to go with the lowest swiftness for some strategic reasons, whatever you think of. So let's say we have this condition, and for example, I don't know, if some enemies are if no enemies are close to you, then you are going for the flag with swiftness set to 63%. And if some enemies are close to you, then you are doing something else. For example, try to eliminate them, or also move towards the flag, but with greater swiftness. So the movement towards the greatest movement towards the flag with greater swiftness, in case of stronger enemies close to you, would be pretty much what avoidant behavior does. The idea behind it is the faster you change position, the higher chance you have to survive, because until the enemies come up with their movement decision, your position will be already changed. So so they have lower chance to actually get you. And also in this case, you can go with some model you're choosing. For example, for 1 nano in this case, and in this case for example, we are choosing the more intelligent one for some reasons. We can analyze. Okay, and as you can see, there's also an arrow from LLM control node. That's because you can actually go further with this decision branch. Let's say. So when you are in these circumstances that this condition is not true, your player is doing this with GPT-4o1, and after he's done executing his decision about the movement, he can go with another decision making. If there's nothing here later, then the next move will be just from the start. So the condition will be evaluated, and will choose one of those branches, go either with this decision or this. And if this is here, then we are continuing with this decision tree branch. We can look at built-in behaviors. What I have, what is being built into the game. So, for example, let's look at this aggressive. So we are starting with from entry point. We are going straight to the branch. So then there's a condition is evaluated. So let's look at a condition. A condition is well, we are defining some relation that either false or true, and based on the result of this relation, we are choosing either this branch or this branch. So let's look what relation this behavior is actually defining. What is at the left side of relation? On the left side is this player. Relation is distance, and less or equal, and right side of relation is result of this player selector. Let's see what we are selecting here. The player selector is node that lets you select players among all the players that are in the game right now. If you omit on this left side, the default is all the players in the game besides yourself. So this player selector is using relation enemy, and we are choosing all the players that satisfies the relation team enemy. So all the players relation team enemy, and right hand side is our player, this player. So what it means, we are selecting all the players that are enemies to this player. So in other words, we are choosing all the players that are not within the team with our player. From a result of this player selector, we are from all enemies. We are choosing the weakest one. So all enemies weaker than this player. So this is okay. We have so result of display selector is defining in other words weaker enemies. So weaker enemies are the input to this condition. So what we are doing actually now, the left hand side is this player, relation is distance less or equal, and right hand side is weaker enemies. So this condition is checking if there are any weaker enemies closer or in equal distance to 5. So are there any enemies in distance to our player 5 or less? If not, then we are giving control to LLM. This is empty, so we are using model defined in game configuration in what is currently configured in main menu of the game, with swiftness set to 20%. So it will be a lot of steps with pretty slow execution, and we're targeting flag. In other case, when this is true, so when weaker enemies are in distance 5 or less to us, then we're taking display selector that will select for us what this condition is operating on. So it's getting the same relation as this condition node, the same and the same inputs. And so we are in this case we are targeting the weaker enemies with swiftness to 80%, so the decision and movement are happening faster, and also using the model set in the main menu. To avoid is also configurable in behaviors, but in this case it just left empty, and when it's left empty it's using the default, and default is stronger than enemies. So we are ordering explicitly our players to avoid stronger enemies. So what they do with this order is up to them, but usually it means they're just trying to be not close to stronger enemies, and specifically, well, for sure not at the same position, because it will result in elimination of this player. We can look with on aggressive fast. It's very similar, but in this case the default, when we are targeting flag and no weaker enemies are close to us, then we have swiftness set to 85%. So it's very great movement speed and very quick decisions. And in this case it's 100% swiftness. But every other settings are pretty much the same. Oh, also I think, yeah, the radius for checking if weaker enemies are close to us is set to just 2. In aggressive, the base version of aggressive behavior, it was 5. In this case it's 2. So if weaker enemies are in radius 2 or less to us, then we are generating just 1 step towards them. Well, probably that's what we are ordering our player to do, but he might decide that he will do something else. For example, still target the flag, but still be using the higher swiftness, but that's not player's decision. That's what's defined in the behavioral blueprint. But the target is just suggestion with our order that he can just not listen to. Okay, so that's pretty much it. Maybe we could create some custom behavior, but I don't have any idea for it right now from the top of my head. Maybe we can do something stupid and see if the model will actually listen to this, because well, all the models, all the players are actually aware what is happening. I mean, they're aware what are the rules of the game, and if we, for example, order them to target their teammates, then they'll know it's stupid to do. It doesn't make much sense, but we can check what will happen. So okay, play selector, and we'll select our allies. So let's do something like this. So all the players that are allies to our player, and those are the targets. Swiftness, let's say 50%, something like this, and model, let's stay with the defaultly set in the settings. And well, it's stupid to do, but but in theory, our orders are so that that all the players should target their allies, so they should constantly collide and just ignore the flag altogether. So let's export this, call it dumb, and let's use it in the game. Sorry, I have to copy my API key. And let's load external behavior. Where I saved this, I think it was it was it. It's loaded. Setting for 1 nano for all the players. Let's stay with 3 teams or 3 players per team. And okay, let's see what happens. Well, all the players still are aware of the rules of the game. That actually capturing the flag is able to gain them some points. So they probably will target the flag anyway. But as you can see, the collisions between teammates are really happen really often. And the models are probably confused that they're actually going in circles because they're trying to catch each other. It's pretty funny. And they're in fact completely ignoring the flag. They're just playing around with them. Hopefully this game will ever come to an end, because this oh yeah. And actually the team that was going around chasing each other won, because all the others eliminated each other in some other way. So the green and red were fighting with each other, and the blue team was chasing each other within the team, completely ignoring the flag. Pretty funny. Okay, that's as you can see, you can even do something this dumb with this game. And I think I mentioned all the features I wanted. That's how it looks. It's also really fun to play. It's already really fun to play, but it has much more potential than that. I hope it gains some of your interest, and I'm hoping to be able to put some web accessible demo on the web in some time. I want the game to compile to WebAssembly and put it on the web to be accessible, but in some feature cut version. So probably no external models, and maybe some other feature cuts. But maybe just it. So only the built-in behaviors will be possible to use, and and I want to put the game in some short time into Steam wishlist to be so you are so we'll be able to track the development and suggest new features and how you like current state of the game. And thank you for your attention, and bye. See you in future devlogs.